Have you ever wondered why some materials feel colder than others? It all comes down to a fascinating property known as thermal conductivity. This property determines how well a material can transfer heat. It's the reason why when you touch different objects, some feel colder or hotter than others. The question then arises, why does a metal spoon feel colder than a wooden one? To answer this, we're going to delve into the captivating world of thermal conductivity. Let's find out. When it comes to conducting heat, not all materials are created equal. Let's take metals, for instance. Have you ever wondered why metals are such superb conductors of heat? It's all down to their atomic structure. You see, metals are made up of closely packed atoms that are surrounded by a sea of electrons. These electrons are free to move about, which allows them to carry thermal energy from one part of the metal to another. Think of them as tiny, super-efficient delivery trucks, transporting heat from point A to point B in a flash. This electron mobility is why when you touch a metal object, it often feels colder than its surroundings. But here's the catch, the metal isn't actually colder. It's just that these little electron delivery trucks are whisking the heat away from your hand so quickly that it feels colder. Now, let's contrast this with materials like wood or plastic. These materials are poor conductors of heat. Their atomic structure doesn't allow for the same level of electron mobility. So when you touch a wooden or plastic object, it feels warmer because it's not as efficient at pulling the heat away from your hand. So the next time you touch a metal railing on a cold day, remember, it's not that the metal is colder, it's just better at stealing your hand's heat. But thermal conductivity isn't just about solids. It's a marvelous world out there, extending far beyond the realm of the solid state. Liquids and gases too play their part in this thermal drama, albeit with a lower degree of thermal conductivity. Picture this, a hot summer's day and you're sipping on a cool drink. The ice melts, but why? It's the thermal conductivity of the liquid water transferring heat to the ice. But remember, this conductivity is much less than what you'd find in solids. Now, let's talk about the air around us. Ever wondered why we layer up in chilly weather? It's because air, a gas, is a rather poor conductor of heat. Each layer of clothing traps air, creating insulation that keeps our body heat from escaping. So, you see, thermal conductivity is not limited to solids alone. It's a fascinating interplay of heat and matter in all its forms. Whether it's a solid, liquid, or gas, every material has its unique thermal conductivity. But what influences a material's thermal conductivity? Well, it's not a one-size-fits-all answer. Several factors come into play. First off, temperature. As temperature rises, the particles in a material move faster, and this increased kinetic energy can enhance thermal conductivity. Next up, pressure. Generally, as pressure increases, particles are packed more closely together, which can improve heat transfer. However, this isn't always the case, particularly in gases, where increased pressure can actually decrease thermal conductivity. Finally, we can't overlook the composition of the material itself. Different atoms and molecules have varying abilities to conduct heat. For example, metals like copper and silver are excellent conductors because their atoms are closely packed and they have free electrons that can move and transfer heat effectively. So, temperature, pressure, and composition. These are the big three that play a crucial role in determining thermal conductivity. Understanding these factors can help us make smarter decisions about the materials we use in our everyday lives. So, what have we learned about thermal conductivity? We've delved into the world of heat transfer and discovered that thermal conductivity is a measure of how well a material can transfer heat. We've seen that this property varies greatly among different materials. Some, like metals, are excellent conductors and transfer heat rapidly. Others, like wood or rubber, are poor conductors or insulators and transfer heat much more slowly. We also explored how thermal conductivity isn't limited to solids. Liquids and gases also have their own unique conductive properties. Remember, it's not just about the material itself, but also about its phase. Moreover, we learned that several factors can influence thermal conductivity. Temperature, density, and even the molecular structure of the material can all play a part in how well it conducts heat. So the next time you find yourself wondering why some materials feel colder than others, you'll know it's all about thermal conductivity.